Okay, everyone, welcome to Friday afternoon NORA webinar. Today we have Pedro and Anis Yazidi here. Pedro works as a statistical and mathematical models about mathematical and statistical models, and also applications to health, engineering, and society. Since 2019, he is a professor of scientific computing at OsloMet, being previously in Germany at University of Osnabrück. Is that correct pronunciation? And Anis, he received his master's and PhD degrees from the University of Agder, Grimstad, in 2008 and 2012. He was a senior researcher with NORS in Norway from 2014 to 2019. He was an associate professor with the Department of Computer Science, OsloMet. And now he is currently a full professor and leading the research group in applied artificial intelligence. So today they will present a very exciting new center. They will present NordSTAR. It's a new Nordic Center for Sustainable and Trustworthy Artificial Intelligence Research at OsloMet. And NordSTAR is one of the 5 research environment at OsloMet that recently got designated as an excellent academic environment. So congratulations with that, Pedro and Anis. They will show movie, they will have some slides, and please everyone use the chat or Q&A button to post questions, and we will have some discussions after the movie and after the presentation. If I have understood you correct, Anis will start first then with some slides, and then they will show a movie about the new center, and then Pedro will end with some slides before we'll take a debate and questions. So please, Anis, the screen is yours.
Yeah, thanks a lot, class, for the presentation. It's a joy to be invited to this webinar, NORA webinars. So today I will be presenting NordSTAR, our new Center for Sustainable and Trustworthy AI research. So NordSTAR is anchored at the OsloMet AI lab. So it's a lab that exists and is physically located at the heart of Oslo in Piletsstræde, and the lab has different missions. One of its first missions is to conduct high quality research in artificial intelligence, but also other aims of the lab include educating students in AI, outreaching activities, fostering partnerships with national and international research groups and industry, and also host presentations, talks, conferences, meetings, hackathons related to AI. So when it comes to research, the AI lab is at OsloMet is an umbrella for different research groups working with AI directly, and also not only at OsloMet but also at SimilaMet. So some of the groups that fall under the umbrella of the AI lab are the Applied AI group, which me and Pedro belong to, and the Department of Machine Intelligence, which is a group focusing on AI at SimilaMet, and other groups working with AI. So this figure depicts the research areas of the NordSTAR. There are 5 areas, and for each area there is a leading principal investigator and different participants. So now I will move to presenting a video that is done by the center co-directors, me and Pedro, and the 5 PIs.
Hi. With the increasing development pace in the field of AI, such as the advent of deep learning and with its widespread industrial adoption, it's hard to point out a human activity that will not be affected by AI in the near future. However, this fast development of artificial intelligence and its achievements brought new challenges in the basic AI research. In our vision, we focus on two of them. First, state-of-the-art algorithms in AI demand massive computing power and energy, particularly to handle the ever-increasing big data repository, which impose AI systems to scale their computational and energy efficiency in proportional to all available data. In a recent study by MIT, training a natural language processing AI algorithm was shown to produce as much CO2 as the CO2 produced in the lifetime of 5,000 cars. In other words, future AI must be sustainable. Second, due to their complexity, AI systems are also threatened by human factors. Above all of them, lack of trust. The most sophisticated AI models are able to achieve superhuman performance, but lack transparency on how they generate their predictions. Moreover, this lack of transparency makes modern AI vulnerable to biases and adversarial attacks. Because of that, cutting-edge AI methods are ignored by potential users, and several of the AI applications still rely on old-fashioned AI, which is less precise but more transparent. Thus, future AI must also be trustworthy.
Let's take an important example: health, or in particular, intelligent health. To diagnose, treat, and prevent several diseases, one needs to collect data from different subjects, which should be handled in a secure and safe way. Several examples of mental and brain disorders could be given. In all cases, the different strategies to store and access sensitive data are important in this scope. But also, one needs to prevent adversarial attacks, which are known to mislead the diagnosis and violate privacy by divulging that the patient was part of the training data. Security and reliability is needed, but it is not enough. Several AI algorithms can nowadays use massive quantities of data to detect particular features associated with one particular health stage, enabling the diagnosis of specific diseases. Still, the uncertainty of such diagnosis needs to be quantified, and the prediction itself needs to be explainable and understandable. What is behind those data patterns that makes them reliable indicators of some diseases? Is it possible to decrease the uncertainty of our diagnosis by combining the data sources in a different way or using other models? These are the important questions in the scope of what we call explainable AI, some of them related with, of course, data security and reliability. So we have security and reliability on one hand, and we have explainable or understandable AI on the other. So now we also need to consider different human factors of social, psychological, and legal nature. Clinicians may be aware of the most accurate diagnosis provided by an AI algorithm and still neglect it. What makes clinicians trust the prediction of a computational algorithm? What level of understanding do they need to rely on these algorithms as they do on their empirical knowledge? Moreover, we know that humans may or may not provide their private data, depending which data it is or how it is collected. So these questions are usually addressed in the scope of what we call human factors in AI.
Together with this, there are two further challenges in a future scenario of increasing amounts of data: the increase of energy cost and the computational complexity, the two main features around which we define our concept of sustainability in the scope of AI. Each one of these challenges appeals for new ways to perform computational tasks, which will have an impact in data security protocols and how explainable models are built and designed. AI promising approach to optimize energy costs is to use neurocomputers. Finally, future computer science aims at quantum AI. Quantum computers will use quantum effects to speed up the computational efficiency of present AI algorithms. In the scope of intelligent health, for example, when searching for new treatments for one specific disease, classical computers would search sequentially all possible chemical composition of new possible drugs and simulate its effects. while quantum entanglement will enable us to explore the huge collection of possibilities in parallel. For searching a treatment, quantum AI algorithms are appealing, but their computational efficiency can also be used to decrypt security protocols in an efficient manner and hide even more the explainability of the algorithm.
Our center, NordSTAR, is focusing on establishing and developing a new paradigm in artificial intelligence, so-called Sustainable and Trustworthy AI. This new paradigm will enable the development of new design principles for AI tools, which are both sustainable and trustworthy by design. To this end, NordSTAR will cover all necessary topics related with trustworthiness and sustainability, such as security and reliability, model explainability and uncertainty, trust, and energy and computational efficiency. To approach all these topics in a comprehensive way, NordSTAR consists of 5 different research groups. First, security and reliability. Second, explainable AI. Third, human factors in AI. Fourth, biologically inspired computational systems. And fifth, quantum AI. These 5 groups will coordinate in a cross-disciplinary activity aiming at sustainable and trustworthy AI tools for the present society demands and at facilitating possible developments of AI technology in the future. Let's look to each one of these research groups in more detail.
The past decade witnessed a revolution in the use of AI and machine learning systems. We have deployed those systems in all parts of our society. We have deployed them in healthcare. We have deployed them in transportation. We have deployed them in banking to protect against fraud. We have deployed them in online marketing, in social networks, recommender systems. We have deployed them just for leisure. So all of us have some personal assistant, be it Google or a Siri or a Alexa to help us. So the AI systems are now ubiquitous. They're around us. And this is just going to increase. They're going to creep in to more aspects of our society. They're going to help us with diagnosing, medical diagnosis. They're going to help us with driving cars on behalf of us when driverless cars arrive. So the more we depend on them, the more critical they become to us. This is why we in NordSTAR would like to build trustworthy and sustainable AI systems. Critical systems, like any other critical systems, we need to ensure their reliability, security, and safety. And in NordSTAR, we're going to approach this problem from 3 different angles. So the first one has to do with the communication between AI systems. Today, AI systems are just centralized. So we have a huge processing machine, computer, servers, one place with the data, and they do all the magic for us. In the future, this is going to be more distributed. Why? Because we'll have cheap connectivity. Because we need AI everywhere. And with cheap connectivity that's coming with 5G networks, with wireless networks, we'll be able to send huge amounts of data very fast. And at the same time, we'll have sensors around us, IoT sensors, Internet of Things sensors, collecting data, and they'll be part of this huge AI system. Once this arrives, we need to ensure the integrity of the communication, the reliability of the system. We don't want our society to stop functioning because of an outage, because of a communication problem, a power problem, because the AI system got disconnected. We don't want our society to be crippled because of a cyber attack. So in NordSTAR, we'll be looking at this. Another aspect in NordSTAR is to look at AI systems that interact and learn from the environment. So those AI systems, we call them reinforcement learning systems. Just like children, they learn by trial. They just attempt to learn and try things and then learn from that. Probably some of you have seen the AI program that won the Go game against Lisa doll. That's a reinforcement learning system. So we'll be looking into the safety and security of those systems. And finally, of course, robots. We'll be looking at security and safety of robots. Robots are everywhere. Today, if you go to factory floors, you have robots. Many places you have robots. At home, you have robots. But now this is becoming even more ubiquitous with the pandemic. Robots will be at stores. Robots will be in warehouses. So robots will be more and more robots around us, less and less invisible like today. So we need to ensure the security and safety of the robotic systems. So together, researchers from OsloMet, SimilarMet will be collaborating on tackling those problems.
So the first part is what's called explainable AI. And the most popular methods within AI, usually it is hard to understand why they made a specific recommendation or prediction. So in this part of the project, we are looking into different approaches to make it easier to understand or find explanations why the methods make a specific recommendation or prediction. In the second part, we are looking at methods to quantify uncertainty in the recommendations or predictions from the system, because usually the methods are not equipped with this ability. So these are specifically the two parts we will look into in this part of the project.
AI innovation is inherently different from traditional innovation as we have seen it today. This is due to the very particular characteristics of artificial intelligence or machine learning techniques that are being discussed and adopted in many different sectors of society. Controversies, for example, arise around the automation of clinical judgments in healthcare, or the public sector in the Nordic countries and abroad has been exploring the adoption of automated algorithm for taking decisions about requests for benefits from citizens. Or the police in different countries has been applying AI-based techniques to predict where crime will happen. All these different applications of AI take to the foreground very different questions that are new for us as researchers in ICT. The human factors in AI group in NordSTAR, based primarily at NTNU, will collaborate with researchers from OsloMet and other institutions by providing a complementary perspective to the problem of AI adoption. We will in particular focus on AI in context. So we will leverage our expertise to understand how decisions in AI-based systems are taken, how they are made, and how algorithms are developed by adopting what data, how these data are produced, and how the output is used in decision-making processes in practice. What this means is that we will take a holistic perspective where we will focus on the long-term processes through which the social, the more technical, and the organizational aspects associated with the implementation, development, and adoption of AI and machine learning systems unfold. And crucially, what we will do is to not only focus on solving these problems right, but also making sure that we identify the right problems that emerge in practice. So we will ask questions like, how do people engage with technology in day-to-day practices? So not only from the perspective of those who are supposed to maybe take decisions based on algorithmic systems, for example, in the public sector, workers in welfare organizations who have to decide whether granting benefits or not to citizens, but also from the perspective of the citizens. How do we ensure that AI systems are meeting the two aims of NordSTAR. So not only sustainability, but also trustworthiness. So how can decision-making processes become intelligible and trustworthy for all the parties and stakeholders involved? So specifically, we want to target the black box problem. So making sure that AI decision-making processes become more intelligible for everyone involved, because the adoption of these AI and machine learning systems has a direct impact on the way people work and live.
Hi, I'm talking about the bio-inspired computational system research area of NordSTAR. In this research area, we want to explore efficient computation by looking at how biological systems compute, and in particular the brain. The brain has a massive computational power, and this is a result of a bottom-up process where the components of the brain, the neurons, interact at a local level and give rise to a self-organizing behavior. So we want to use an approach that rather is bottom-up instead of the current top-down approach that is used for AI systems, where the components of the system are precisely engineered and put together. The brain is a very optimized computing machine. It uses very little energy. It runs on 12 watts. So current AI methods are very energy hungry, and in particular, the learning process is the bottleneck of the algorithm, is using a lot of energy and therefore also producing a lot of carbon dioxide. For example, one popular model, BERT, famous language model from Google, has a energy consumption that is roughly the same as a round trip from New York to San Francisco. If we want to scale up modern deep learning methods to achieve the same computation as the brain, we might encounter problems in terms of energy consumption, in terms of environment. The main problems of the current deep learning methods are that they are not necessarily bio-inspired. They are not biologically plausible in the way the learning happens. In the brain, the learning happens at local level with local signals. And rather, in current deep learning methods, we use global backpropagation of errors. Also, the brain, as we have mentioned, is very much energy efficient. And by having models that are more similar to the biological counterpart, we might also have a better explainability of the AI architecture by using common methods that are used in neuroscience. If we want to make better bio-inspired models of artificial intelligence and neural networks, we have to look at how biological neural networks work. In order to do that, through modern biotechnology, it is possible to grow biological neural networks in vitro, in small petri dishes. And it's possible to send inputs, electrical signals to them, as well as record electrical signals from the network. And therefore, it's possible to create a neural network of a biological kind. By looking at the electrical signals that neurons use to communicate, as well as other physiological signals from biological systems, it is possible to create better biologically plausible models of AI, as well as look into energy-efficient hardware, and in particular neuromorphic substrate for spiking neural networks.
The matter of trust is super important. And the question is whether we trust to AI and its technologies. And the answer, perhaps, we do not. We can talk about how fancy is it until it gets personal. And we can imagine a situation when we need to talk to our bank about mortgage details, and we are given two options, either to talk to a human operator or to AI. And I'm quite confident that most of us will take the first option. And more dramatic, if it's about a life-threatening disease, God forbid, of course, and there is a need for personalized medical treatment. And again, we have two options, to have a human doctor or super smart AI. And I think all of us will take the first one. And why? We have no answer. Why? Do we need someone to blame at the end? Do we need to have someone to be responsible, a peer, or we need just a human face on top of everything. And this is explanation why I took this topic, the subject of the initiative, as personal one, because I myself have no answer to the question, and it resonates with my thoughts and concern. So what is quantum AI? It's a perfect marriage of buzzwords, and it is a mystery wrapped in an enigma. So, and it's also a subject of hype currently in research community. It is part of quantum computing initiative, and researchers think how to profit and benefit from quantum effects and phenomena in order to increase efficiency and performance machine learning algorithms. Quantum computing per se is currently big hype in public media, and public media hype is a strange thing because it is supposed to make things clear and explain them, but instead it does the opposite. It erodes the trust and it widens the gap between technology and society. The same happened in scientific community with quantum AI, because there is a hype in scientific community as well as in society, and it emits vibes. And the number of publications since 2012, I think it's about factor 5 by now. And there are already several journals established, and one of them is quantum machine learning by a well-respected publisher, Springer. So the question is, what is that? Is it a real technological breakthrough or just a triumph of right chosen PR strategy? Scientists, they enjoy it because it's a room for their creativity and curiosity. Real outcomes remain a question. It could be that at the end, quantum AI delivers nothing. It could be that quantum computers, they do not catch up with all these ideas as technology, and there is no way to realize them. It could be that it's something very new and very promising. And it could be that it will change the world around us in 5 years. That is possible. There are two steps I see as a way to understand and to build a trust in quantum AI. First is to sort out all this avalanche of ideas produced by researchers so far, and to figure out the most adequate ones, test them with real problems, if it's possible, to see results, and then by using these results to figure out the best strategy to build the trust in quantum AI. So this is a plan for this project within our joint initiative. Thank you.
So all in all, how would what we call sustainable and trustworthy AI be possible in a future world with exponential increase of data or with quantum computers? As is exemplified previously, the answer can only emerge within a center's environment, coordinating the 5 research areas that we described. And in close collaboration, this should be done also with partners and collaborators able to test our new tools in AI, providing feedback for possible further improvements. Now, NordSTAR will be such a center.
So now, after seeing this video, what is still missing is something that is very important. As you understood, probably we have these 5 different research areas that now in the overview that Anis was showing you, we have focus, let's say, in basic science. So we want to develop algorithms with all these different features about energy and computational efficiency, the human factor part with explainability, data security, and so on. So all these parts are important, but of course that we need then to interact very closely with people in different contexts that use and apply these algorithms and these tools.
So when we submitted already our proposal for SFF last November, we had already a close contact with AHUS that are very interested also implementing and developing AI algorithms. And so we have this kind of teams, applied teams, so satellite groups that we will interact very strongly with NordSTAR in the next 4 years. So we are in the very beginning. So we just started last month, basically. And we have here mainly two challenges. The first one is to continue developing the skills and the knowledge that we were developing in these different areas, separated from each other. The second one, it's perhaps more challenging, is to find perhaps new ways now to interact and try to merge these different research areas in order that we can develop further these AI tools in a consistent way. So those of you that saw Stefano's initial seminar in NORA, I think exactly 2 weeks ago, February the 5th, you learned from Stefano that he's leading these two projects about learning from real neural networks, from biological neural networks, to learn how these networks learn and can learn and solve some computational problems, and try then to find ways to through data analysis, try to find ways to grasp the main features of these biological neural networks, and then use them with that knowledge to construct other kinds of models that are easily implementable in a computer. Now, related with that, next month we will start participating in a very big project, in a European project, which is called AI Mind. It's being coordinated by Oslo University Hospital. Our task, let's say, is to build and implement a connector that can read different data from the brain, basically EEG, and then try to map those set of signals into networks of functional networks that can identify particular patterns of brain activity. Now, together with that, we will call this the AI Mind connector. We would then try to map this brain activity with other data from patients in order that we can make diagnosis in the context of dementia. So this is a big project started this year, and it will start officially, I think, in March. We had already the kickoff meeting. Most probably there will be some now positions that will be announced soon to have PhDs working in these two tasks. Now, a little bit beyond that, things that are still not ongoing, this is not ongoing work, is basically a proposal that was submitted recently this month together with AHUS, where we will make our first trial to establish what we call a kind of triangle of development of these tools that we are trying to develop. So we have basically here 3 nodes. As you can see, we have a triangle with 3 nodes. NordSTAR would be basically on this first node on the up left corner, developing AI tools that should be then trained using clinical data provided by a group at AHUS. They are working basically in cardiac care. So we will now specifically focus in that for cardiac care, but of course that the aim is to develop this kind of framework or development chain to be then applicable then in other contexts. Now, mediating these 2 nodes, the applied one where we have the data, that will provide the data for us to construct the algorithms. And then we'll also use then our algorithms. And they should have a kind of opinion how good these algorithms are for their own goals. So in order that we can receive back this kind of feedback from the experts that are really using our tools, we will then have a third node that will then develop this kind of questionnaires and tests that are aiming not only to validate how good our tools are, but the idea is also then to take back this feedback and translate this in some way, translate it in some quantitative stuff that we can use to improve our tools, and then develop these algorithms iteratively with the node at Aarhus. So this is the kind of approach that we think we could now extend to bridge then between also the other research areas at NordSTAR. And just to finish before the discussion, perhaps I would like to advertise 2 open positions now. One for a PhD in quantum artificial intelligence, and another postdoctoral research fellowship in trustworthy AI, with the aim to bridge between the main aim, so that it's open for a project that the applicant wants to submit, but our aim would be to try to bridge between explainable AI and one or more of the other research areas in NordSTAR. So our aim now is not only to develop each one of these 5 research areas, but to bridge and create really connections where and convergence of synergies from the different research areas. And that is all for now, and we are open then for questions and comments. Thank you very much.
Thank you so much, Anis and Pedro, for a very nice presentation. And it's very exciting for me to see both NordSTAR and many other projects, AI projects in Norway, and also see that OsloMet, that AI is so strong in OsloMet. I also want to mention the very good project that you're part of. You mentioned AI Mind, because I see now that OsloMet is very well organized, and we are also collaborating within the NORA network. And that was actually, I think, kind of a perfect kind of how NORA should be, because this started with Digital Life Norway and coming to NORA because they wanted some AI experts. And then I saw that Anis and co-workers had published this nice paper in EEG, AI and EEG, which was just what they needed. So NORA reached out to the NORA network, and also through the European network through CLARE. So we also brought people in through the CLARE network. And this ended very successfully with a big EU grant, 14 million euros, which is a huge project. So congratulations to you all. We have some questions, and please, everyone, just continue asking questions, and I will read up some questions here, and it's also possible to post them both in the Q&A and in the chat. A long one first, so I will read it up. Hello, very interesting. I'm curious whether NordSTAR will also explore sustainable AI in relation to multi-agent artificial intelligence models. Many such models are being used to analyze and forecast the conditions and mechanisms that contribute to more sustainable societies or indicate why they will collapse, and to facilitate more trust within populations. And these bring up ethical challenges similar to the ones you are discussing. Will NordSTAR also foster conversations about multi-agent artificial intelligence models and social simulations, as well as traditional AI and machine learning? Anis and Pedro.
Yes, so so in fact we are in collaboration with research institute at OsloMet called NIBR. It's a research institute that is mostly focusing on social science. And one of the projects we are building up is around exactly what was described. How can we use multi-agent systems in order to to simulate a post era of after oil is over, where we have a transition from oil industry to green industry. And so this is one example. So there we try to use the theory of multi-agent systems to show how this transition will happen, how whether this transition will be smooth or not, whether new jobs will be created or not, and how people will change their profile, their education, and their even move from a region to another, depending on what will happen with the oil industry. So this is a kind of example, but I think the intersection between social sciences and artificial intelligence and multi-agent system is a very rich area of research, and that can also fit very well within understanding how we can transition to more sustainable society, because this is the question. So we want to become sustainable. Cities needs to be sustainable, but in practice, how to do it? Even in Norway, we want to be sustainable, but we are depending, for example, on oil. So we cannot do it right away. So there should be a kind of smooth transition. So AI can help in this regard. So when they can add something in that project, at least we have the idea of so-called, it's a little bit similar to digital twins, but it's where the agent need to be, we need to reflect, it should not be a simple agent, but an agent that can make decisions similar to human beings. And the best way to do it is to have some kind of training data. And in this case, for example, it was about, we have the register data is well-structured data that is kind of detailed, that where we can see how people make decisions to move from a place to another, from a job and another, in a way depending on different characteristics.
Thank you, Anis. This was Leron Schultz asking, and he had a short following up question. Thanks. Can you spell or put in the chat the name of the institute you mentioned at OsloMet that is engaged in this?
You're right.
Perfect. Next question from Sachin Gaur. Should there be a scope for business models, regulatory aspects in such projects, as AI-related regulation in healthcare and also business models are evolving?
The question is very good. Perhaps I just want to add one thing of what Anis said to the previous question, which is also very interesting. So the answer, as Anis said, is yes. We are also approaching this kind of multi-agent models. But just to be clear, that of course that we can create algorithms to address problems about ethics in society, energy transition, how people behave, and so on. This is possible. The focus is now a little bit more on the other way around. So we create some algorithm that in the end of the chain should be used. The end user is, for instance, a clinician that needs to make some diagnosis of a patient. And in that sense, the clinician needs somehow to have trust on this algorithm. He needs to understand how this algorithm functions. He needs to understand why the algorithm is retrieving these predictions and not other ones, in order that he can really make a good decision about, I don't know, therapies or whatever. So it's a little bit the other way around, is not to create algorithms to approach problems in ethics, is try to develop algorithms that can be used in an ethical way and can promote trust from the perspective of the end user. But of course, we address both of them, as Anis was explaining. The other one about the question about business models. Yes, that's important. And last end, we expect that AI, so that this framework, this kind of development chain can contribute regulation in healthcare and so on. But of course, now our first aim here is about science. So we want to see if it is possible to develop, to have a framework where we can develop this kind of algorithms in this new way. And if somehow they provide something new in the end of the chain, then I think last end will be the experts in those specific applied contexts that will decide if this implies a change in new regulations or protocols when handling these new algorithms.
Thank you. Yeah, I can also add from NORA that we will also apply for EDI, European Digital Innovation Hub, within AI and specifically in AI and health. So this will also be issues that the NORA network as a whole will work on. The next question from Sachin Gaur also is also add to it, please, interoperability and standards aspects when it comes to data storing standards and defining other fundamentals.
I did not.
Yeah, I guess should there be a standards when it comes to both data handling, I guess, in general? Should it be standards, or how should it do that? Please, Sachin, also ask a follow-up question if you want.
Well, I think this is kind of a general question related to data science in general, because it is known that most of the data scientists, most of the job usually goes into preparing the data itself for analysis. So I guess yes, definitively it's like if we find ways at least to have some kind of well-known formats for data that people agree on. For example, even we take the example of, for example, health data. Even if we take EEG data or any type of data, it comes with so many formats and it's so difficult to handle this type of data. So finding ways to reduce this pre-processing time, it's always useful. I think that's one of the challenges, because when people speak about data science, the reality is most of the data scientists spend a lot of time to structure their data, to process it before they can even run a machine learning algorithm. Yeah, and also another reply to this question, I think, is what is happening now. And now one of the businesses now is providing the data itself, providing those well-structured data sets. And there are some companies that are selling this well-structured data that is easy to pre-process, that is easy to work on. So, for example, to train your algorithm. So this is the dream of people working with machine learning. So,
thank you. We get a lot of questions here.
Can I interrupt? Sorry,
yes, Pedro.
Sachin Gaur in the chat made, so he tried to revise the question. My question is that if you want other hospitals to adopt such system, is there some new file formats or representations that you expect to come out as an outcome? That's a very good question. So in fact, we are planning in this proposal that we submit together with AHUS in this development triangle that we submit this month. The idea is at a later stage, so after developing the tools in this iterative way, as I explained, the idea is to see up to which extent we could then apply this procedure to other departments first, perhaps within AHUS, and then extend this to other hospitals. And of course, they know what are there are some protocols, of course, and some guidelines that need to be followed. The idea is then to follow them in order that this can be implemented in those contexts. I hope this answers the question now. Sachin?
That's good. There are also some questions to the explainability. I will also mention that Mikael Riegler had a great talk. He is at OsloMet, so I guess also collaborating with you. Had a great talk about AI in healthcare, where explainability was part of his talk. So yeah, all of our webinars are available at the NORA homepage. So please go in and also and have a look at that webinar. Anis, did you have something to add?
No.
No. Then I will turn to the next question. What are the Norwegian regulatory authorities like ISO for AI pipeline algorithms to get approval? Or EU authorities, or are EU authorities valid in Norway?
To be frank, I'm not aware of any effort to at least regularize these types of operations. No.
Perhaps you can answer this question, Klaas, no?
Yeah, I can add that, of course, if you want to get an approval as, for example, a medical device in Norway, you have to go through Legemiddelverket, and it's ultimately want to approve it in EU then. But Legemiddelverket is the way to go through it.
Yeah, but he said the question here is how to approve the AI pipeline. I think it's whether of course I'm not sure whether here we are thinking about ethics, which is the ethical committees, or like having a kind of standard to pre-process the data. So.
Yeah, that's true. Please, this was a question from Shairitra, so please follow up if you have more questions, if this was general or if it was if you were thinking about medicine specifically. Let's see, do you have any more questions here? It's some discussions at least. One from from earlier on. Do you have plans for development of new programming libraries? If so, how will this compare to existing ones?
At least for now, no. And I can explain why. Because if we look at when it comes at least to machine learning, especially the deep learning part of it, there are some programming libraries, but if we look who are behind those libraries, we'll find that it's Facebook, it's Google, it is Twitter, it is these big, huge companies, and these are the main drivers. One of the main drivers behind AI. So I think it takes a lot of time and effort, and the question whether it's worth spending time on it. And for those companies, yes, it is worth spending time on it, because they do large scale development. They have a lot of development. They want to shorten their development time. But in this course of in the scope of our project, we have I don't think this is something that we want to do.
Mm-hmm. Could I also ask, because you have now, NordSTAR is about sustainable and trustworthy AI, and you also have 5 topics below that. How was the process to decide on these things? How did you go by actually?
Yes.
Sorry, Klaas, about
process. How
the process. You have now. It's very nice to see that the specific centers around Norway, they're more maybe aligned to the EU strategy, I guess. So it's obvious that there are some high-level planning around this. So I'm just wondering, how did you decide on the specific topics that you will cover within your center?
So perhaps this is a little bit of history of the center itself. We didn't tell that in the beginning. What happened is that we had this internal call from OsloMet for all departments and faculties. So this is a extra funding internal in OsloMet, and the idea would be to select these 5 groups or projects that would be funded in the next 4 years, in order that we those projects can gain competence to aim at SFF in 5 years. And what happened, the announce was launched, and we discussed that within AI, and the first discussion was, what are our strengths in AI that we could be competitive in the context of Norway, because of course there are many other groups in AI that are being focused in some of these research areas that we also have here. And what we realized, the fact is that what it's interesting in our lab is not exactly the focus in one of these research areas, but is the simultaneous focus in different research areas that we are trying to bring together. There are other initiatives also within AI. Gustavo Melo is now the head of our AI lab. And we are trying really so NordSTAR is one of these initiatives that really are aiming at making new interdisciplinary work within AI. So what we realized is that these 5 research areas, we had the expertise here, first of all, with ongoing projects in most of them. And we came up then with this idea of bringing together, approaching together this a new way, a framework to develop in a new way, these trustworthy and sustainable algorithms all together. So that's basically the story behind it.
Exactly. We will take one last question now, and then we will end up. We have a question. I am a professional linguist and translator. What do you believe forecast will be the future of AI in language terminology and/or translation? There are good attempts, but there is still much to be done.
Okay. At least I can say something that of course artificial intelligence have made a lot of progress in natural language processing and in translation particularly, but still, if we look at the AI algorithms, what they are doing in NLP is counter and is not this. It's based on, if we look at everything, it's based on statistics. Usually, it's despite there is this deep learning, but it's based on frequency. For example, if 2 words appear together in the same sentence, then there is if you want to make a note or kind of spell checker, then maybe to know what is the right word you want to put, you look at the previous word, and it's based on statistics. The meaning of a word, I don't know, a word that has 2 meanings depend maybe in the statistics in this sentence for doing the correction. But this is not the way that we human beings do. We don't do statistics when we want to do translation. I will not choose the next word based on its probability, because the other words are previous to that word point out that this is the most probable word, because it might be that it's not like this. We humans, at least, we reason in a different manner than machines in NLP, natural language processing. That's why I see that humans, we are better, even if machines beat us, we are smarter. But I cannot project very much about the whole field of this jobs related to translation, and but we know for sure that there are many areas where machines will overtake some of the jobs of we human beings. But I don't think that the machine can overtake 100% of the job. It cannot translate a document without double checking with from humans. So it's always, we cannot. Also, the same comes, for example, to other jobs. I don't know. For example, doctors. We cannot trust the machine at 100% with 100% chance that it will diagnose, for example, some diseases. We need always, at least my belief is, I might be wrong after 10 years I will look foolish when people will look at this, but because it might be the future that machine will overtake many of the jobs. But I think we need always the human in the loop. This is my yeah.
So the answer, Silvina, to your question is you have a very good job. The translation from humans will still be needed in the future. Probably you will start needing the help to be better translators from AI tools, but they will not substitute you, of course. So keep going.
That's a good summary. I agree. Although we should also mention that this was the same they said about chess, that the best combination is the human and the chess engine. But it's not anymore. So,
but it's true that now that the machines are so good in chess, that humans are also now playing more. So
absolutely,
a really bump now about chess is now a hot game in worldwide.
Yeah, that's very interesting. And also Magnus Carlsen, for example, is learning from this chess engine. So the style of playing has changed a bit. So we might also learn from the machines. Yes, I think it's now some minutes past 3, so we will end this up. I just have to say that this is I'm really excited to see NordSTAR, and I will be excited to follow it. And also NORA as a collaborative partner in NORA. It's really exciting to see how much you have done already. But this is just starting. NordSTAR is just starting up, and it will be an exciting project center for the next years. So congratulations to you, and thank you very much
for the opportunity.
Yeah, thank you.
Thank you to everyone. Bye.
Thanks.